Welcome, physics friends, to today 1.4, identifying significant figures. Today we're going to be talking about how do you add and subtract quantities, multiply and divide quantities in science. It's completely different than math. It has to be because math deals in absolutes. Like it is absolutely this. Science deals with measurements. We're only as good as our experiments. Like our experiments are only as good as our measuring devices. So how do we somehow communicate how well we did something to someone else? Like that last bit on the scientific method, communicate your results. How can I communicate my results effectively to say that, oh, I actually measured this really, really precisely, or I didn't measure this very precisely. Maybe you could help me out. We do that with what's called significant figures. And lucky for you, I have a patented method, a method that I have developed myself and published. It is called Significant Figures Are Nasty. Allow me to help you out. Nasty. Significant figures are nasty. This is a mnemonic device that I developed to help people understand, first of all, how do I know which numbers are significant? Now let me tell you. If you remember the word nasty, oh man, they're always so nasty. I never understood they're nasty. That will help. First of all, zeros on the left are never significant. Zeros in the middle are always significant. And you guessed it, zeros on the right, they are sometimes. Now, I'm basically talking about zeros here. Numbers are always significant, like 1, 2, 3, 4, 2, 3, 8, 9, 9, 1. Those numbers are always significant. Any non-zero number is always significant. But the real question comes with zeros. Zeros on the right are sometimes significant if there's a decimal. Then yes. Yes. Yes, they are. If there's a decimal, then yes. Let me demonstrate. 1, 2, 3, 4. That has 4 significant figures. 0.023. They're on the left. They're never significant. This has 2. 890. That's on the right. There's no decimal, so this is not significant. In the between, that's in between them, it's always significant. So 1, 2, 3, 4. That's on the right. It's not. This is on the right, which means it is because there's a decimal, and that means that that one's in between it. It is 1, 2, 3, 4, 5. On this one here, 4, 5, 6, 7, 8. Left, they're never significant. On the right, yes it is, 1, 2, 3. Because there's a decimal, then that one's yes. This has 2 significant figures. All you got to do for these scientific notation ones is just look here. This has 2 significant figures. This one here has 4 significant figures because you just look at that. You don't worry about this at all. This has 2. On the left is never. 1, 2, 3, 4, 5, 6, 7. This has 1, 2, 3. Ooh, because they put the decimal point, then yes. 1,000 only has 1. Here's an interesting tidbit. Why does the rabbit smile? That's right, because he likes physics. How would I make 1,000 have, let's say, 2 significant figures? You might think, oh, if I put a decimal point at the end of it, now it automatically gave it 4. Is there a way to write a number like 1,000 to have 2 significant figures? And the answer is yes. You'd have to write it in scientific notation. Isn't that neat? That's why we call it scientific notation, because in science, we're telling you how precise we measure this. We measured this to the nearest 100 when we measured our distances. Now I'm assuming you're going to get the rest of these. I could go through the rest, but it's all pretty simple. I'll let you practice some. So this has 3, this has 6. So this has 1, because never. This has 3. This has 3. This has 4, and this has 2. So there, pretty simple. Just remember that significant figures are nasty, and that will help you identify which ones are significant and which ones are not. The next thing, adding and subtracting. Now, when you add and subtract, you can only go as far to the right as the least of it. You can only go as far to the right as the least number. Let me give you an example. You count the significant, this has nothing to do with sig figs, it has everything to do with decimals. This goes 3 to the right, this goes 4 to the right, so my answer can only go 3 to the right. So when I actually do this problem, 92.429, and I subtract 44.1289, I'm going to get a number, 48.300. I always round up that last decimal. If that 1 on the end was a 5, it would be 48.301. So this is 48.300. Because this went 3 to the right and this went 4, my answer can only go 3 to the right. We'll do another one. 52.92. 5.92, I'm sorry. Plus 3.9289. So this, my 92 goes 2 to the right, and then this one goes 4 to the right. My answer can only go 2 to the right of the decimal, so 9.85. See it? 9.85. I had to round it up. I'll do one more for you, and then we'll go on to multiplying and dividing, because they're all pretty much the same. So we'll do 8.4 plus 27.3852 plus 6.814. 42.599. Now this only goes, my least is 1. So this goes 1 to the right, this goes 4 to the right, this goes 3. So my answer can only go 1 to the right of this. 42.6. 42.6. Now, why do we do that? When in physics, in science, we're measuring. Like if I told you, go out and measure the hallway, and you measure this distance, you measure that distance, and you measure that distance, and one person is measuring only to the nearest tenth, and somebody else is measuring to the nearest 10, 100,000, the 10,000th of an inch, when you add those values together, because they're measurements, you can only be as precise as the least precise person. Whoever did the worst job measuring you can't be better than that, so you have to lop that off right there. So that's why we do the adding and subtracting. That's kind of why we do multiplying and dividing too. When you're imprecise, that imprecision gets magnified because you're multiplying by that. You're not just adding by it, you're multiplying. So when you multiply and divide, you have to count the significant figures. The answer is how many the least in of the terms. Just like, well, here this is different. We count the decimal points. So here we're going to count the sig figs. This one has 2 sig figs. This one has 2 sig figs, so my answer can have only 2 significant figures. So 0.0074 times 0.099. You multiply that, 7.3 times 10 to the negative 4. I have to lop it off at 2 significant figures. 7.3 times 10 to the negative 4. When you do the e, it's always an uppercase e. It's not, you don't put it up, it's not a lowercase e is the natural log of, I think, 2. You can't do that. Capital E on the bottom, no superscript, no subscript. Next one. We'll do 62.11 times 60 times 201. And then you get this number. Now I can only have one significant figure because this has 4, this has 1, and this has 3. So this is my most least precise measurement, 60. So I'm going to have to round that off to only one significant figure. That's 700,000. You can write it as 700,000. I don't like that. You should write 7E5. Division, same thing as multiplication. You count how many sig figs. This has 2, this has 4. My answer can only have 2 sig figs. So I'm going to take 7,300 divided by 9.389. And I can get 780. Now, I will tell you this. Significant figures causes the most grief, and it will cause you the most grief all year, because every single problem you do, you have to always account for the significant figures. And people get this wrong on every test, every quiz, from now until eternity. This is important. You have to apply the rules of significant figures properly to every problem that you do in this class. Now, questions come up a lot. Mr. Hare, when I'm doing a problem that has multiple steps, should I do significant figures in the middle of the problem? No. Do your significant figures at the very, very end. Do all of the math first, don't round anything, and then at the very end, do your sig figs. Another question comes up a lot of times. Mr. Hare, what if there's an adding and subtracting and multiplying and dividing? Well, you follow your rules of orders of operation. You always do the multiplying and dividing first. Follow those rules. Then you do the adding and subtracting next. Follow those rules. So significant figures, they're very important. They're a way for us to communicate to one another how well we took our measurements. I have like a play that you're going to read in class tomorrow amongst 2 people. It's a lot of fun to discuss this more, and we'll do some more practice with this in class tomorrow.